Now, we talked about single lenses and single mirrors and individually, right? Concave mirrors, concave lenses, concave mirrors, and so on. What about situations where these lenses and mirrors become combinations? For example, in a telescope, in a camera, in a microscope. What happens to images in those scenarios? So let's talk a little bit about those. So combination thin lenses will actually be where you have two lenses, one object, and then you will have two images. One image will be formed by the first lens, and that image, it will become the object for the second lens. Okay, so you are going to treat the two lenses or the two mirrors or whatever combination you have. One lens will give you an image, and then the second for the second lens, that image will become an object. And let's do an example to help us solve that. So let's try some combinations. Use a ray and lens mirror equation to find and describe the final image for the following combination. An object placed 30 centimeters in front of a positive lens, and a mirror, a negative mirror, placed 45 centimeters behind the lens. And number two, the object placed 30 centimeters in front of a negative lens, and a positive mirror placed 45 centimeters behind the lens. Okay, so let's do this. The first example, it says the object is placed 30 centimeters in front of a focal length of 15 centimeters lens, and a mirror is placed 45 centimeters behind the lens. So first of all, what I'm going to do is I am going to draw my optical axis, because I'm going to do a combination. I don't know if it'll be able to fit on here and how it's going to turn out, but we're going to try. Okay, so this is my optical axis, right? So it says I have a lens. So do you see me being very careful here? So I have a lens, so I'm going to draw a lens here. And I'm also going to draw another line here, because I have to do the second example. Okay, and this lens, it says, is 15 centimeters, okay? So it is a lens. It is a positive lens. So my positive lens will be given by that symbol, right? And it has a focal length of, what did it say? 15 centimeters. So I'm going to use 15 centimeters as my focal. And then it's going to be 15 centimeters here. So I'm going to call this F1, F1. And then it says that it has a mirror, which is negative 45 centimeters behind the lens. So I'm going to calculate this to be 45 centimeters behind the lens. It is a mirror. So I'm going to use this as a mirror. Okay. So this is going to be my F1. And this one is going to, for question number one, it is a negative lens, right? So how do I draw a negative mirror? This is how I draw a negative mirror. Okay, what next? And it says it has 10 centimeters. Okay, so the focal length for this one is 10 centimeters. Let's see if I can draw 10 centimeters. So this is 10 here and 10 here. I think that's about right. So I'm going to call this F2, call this F2. Okay, F1, F1. Okay? And I'm going to, here's another thing that becomes very useful. I'm going to make this little symbol that will help me determine where the rays are actually coming from. So it says that my object is placed, what did it say? 30 centimeters. Okay, so my object is placed 30 centimeters in front of 40, 10, 20, 30. So my object is about here. Turn. Or here. And I'm going to make my object 10 centimeters high. Okay, so let's start at the beginning. Remember what I said. I'm going to ignore number 2 for now. I'm only going to concentrate on the first one. Okay, so this is going to be my parallel axis. Again, we're going to use the same ones we've been using. Parallel, chief, and focal, right? These are the 3 ones. but my parallel, I called it with black. And so I'm going to try to get this parallel to my optical axis. It is a positive lens. Here's what I want you to do. I want you to write lens here, and I want you to write positive here. And I want you to write mirror here, and I want you to write negative here. Why? Because that way you can figure out what you need to do. So parallel is going to be parallel to this one. It is a positive lens, so it will converge and converge to go through focal. Good? Done. Okay? So it will go through here, go through here. Next ray that we are going to worry about is chief. What does chief do for a lens? It just simply goes through the middle. Like that. The next one we have to worry about is focal ray. Now, remember this is a lens, so it has to use both sides. So this one is going to go through the focal point here, strikes here, and then becomes parallel. Okay, that's kind of where all three match up. So here's where my image is going to form. Now, this is the location of image 1. Now be very, very careful because this is image 1 location coming from object. I'm going to call this object. Okay? Now this image will become the object for the next inline. So for the negative mirror, we are going to have this to be as our reference image that will move forward. Okay? Now again, rays are going to be the same. Parallel, chief, focal. Parallel, chief, focal. But it's going to, instead of starting from here, it's now going to start from here. So I'm going to regroup and think, ignore everything that happened here, moving onwards from here. Okay, so the first ray always is parallel. It is a negative mirror, right? So this will actually, so first of all, I need to worry about this. I'm going forward. I'm going to call this P2. Okay? This is a negative mirror. What does a negative mirror do? It diffracts, right? So the negative mirror is going to diffract this ray by how much? By this much that it goes through this focal point. Okay? So that's going to be where P2 goes. Okay? The next ray is going to be my chief ray. Chief ray, in order to calculate my chief ray, I'm going to do, it's a mirror because it's going to be reflected back, so it's about 10 centimeters here. Good here. Okay, so this is going to go in towards that. From here, it hits here, and then it hits here, and then it goes here. So this will be my C2. Now since this is a mirror, mirrors only have one side. So it can only use the same focal point, right? So my focal ray is going to go through the same focal length as this was. So it's going to go from here to here, right? Like that. And then it's going to become parallel. Back. So it's going to go here to here. Note very, very carefully what's going on. And I would even recommend that as you're watching this, you should be drawing these things alongside. Okay? Now, again, I have the same problem. None of the rays match up. However, I can extend this one backwards. Start extending things, right? And same thing I can do with my chief ray. I can extend that one backwards. Where all three rays meet, about here, That's where the image is going to form. And that image is going to be that one. So this is I2. Now, how do I use mirror equations, right? The lens mirror equations. Well, that one is actually not too bad either. So we're going to treat both of these independently from each other. So the first one I'm going to do for lens 1. I'm going to call it lens 1. It's going to be 1 over f equals 1 over o plus 1 over I. Okay? Which means it is going to be 1 over 15 equals 1 over 30 plus 1 over I. I calculate that to be 30 centimeters. And that image to be real. Okay? So, what do I actually measure it to be? Let's measure it real quick. I measure it to be about 10, 20, 30. Yep. So I1, I measure it to be about 30 centimeters. Yay! We did that right. Okay? Now, what about mirror 2? So for mirror 2, it is going to be the same exact equation. 1 over f equals 1 over o plus 1 over I. And in this case, it will be 1 over minus 10, because it's negative 10, equals 1 over object distance. In this case, the object distance is going to be 45 minus 30. So this is going to be my object distance. This one. So this one, if I measure it, it's about 15 centimeters. Okay? So this is going to be 15 plus 1 over I2. I calculate I2 to be about minus 6 centimeters. Okay? And let's see if that actually works out. Oh, sorry, wrong side. So this will be 1, 2, 3, 4, 5, 6. Yep. This indeed is about 6 centimeters from here to here. So it works. So my lens equations and my ray diagrams match up. Yay! Here we go. Okay. The other thing that you have to do is magnification. So magnification is going to be minus an object distance over image distance. So the magnification for M1 will be minus 30 over 30, which is 1, which I can measure it to be exactly equal. Magnification 2 will actually be equal 6 over 30, which is about 1 over 5th, which I can kind of see that it's going to be about the same.